Okay, so question 4, question 2, question 3, question 4, and all three of them have started with the definition. The definition, you need to have the underlined words. The total linear momentum in an isolated system remains constant or is conserved. Total linear momentum. So linear is not important, but total is. So the total linear momentum in an isolated system remains constant. And now I'm assuming the next question is going to be a calculation. So if we can just look at our numbers quickly, 3.2, 3.2, 2.6, 2.6. Those are masses. And then we have a 0.4 meters per second to the left, which is on the picture. But here we actually have a number that's not mentioned. It's the time that trolley B reaches the end of the track. So that is actually not mentioned in the pictures. So maybe we just want to acknowledge it somewhere or something, because it's a number that's given in the question, and we need to make sure that we have all the information that we can get from the questions. The 0.4 is a constant velocity, which means the acceleration is 0, and the next question says calculate the distance traveled by trolley B in 1.3 seconds. And I just want to see the mark allocation for that before we get... So that's 5 marks. So that is definitely not an FSA. We need to do more for that. I'm just going to take this definition off here quickly. We need to do more than just FSA. But again, if that's all we can manage, that's all we can manage. In momentum questions, in question 4, direction is incredibly important. It is almost always at 2 directions. This is an explosion, if you want to know. But I just want to show you here, the version of the formula that always will get you the marks is this one here. So I'm not really interested in that first one. However, if you want to use fancy math symbols, you go right ahead. But I would just always write this one. However, you do need to do some sort of subscript. So you can't write you can't just write MV plus MV equals MV plus MV. That statement is basically the definition that you just wrote. It's the total linear momentum in an isolated system remains constant. So on the left-hand side of the equal sign is before the spring extended, and on the right-hand side is after the spring extended. So you get a lot of numbers in this question. The masses are typically quite easy to get. So 3.2 can be MA. So MA can be 3.2. MB can be 2,6. Now we have VA, VB in the beginning and VA, VB at the end. Before the spring was released, you can see in the picture they're just sitting there, and the story confirms it. It's at rest, which means VIA and VIB are both 0, which is why you could write the left-hand side of this thing as MA plus MB and then just have one initial velocity. Because it's an explosion, they start out together and end up apart. But otherwise, you just sub in 0 twice. No problem. So here, if we just go to the next line. So there, they just subbed in 0. You must sub 0. Like in Mortal Kombat, you must sub 0. So you need to put the 0 somewhere. You can't just leave nothing there, because that means you might have just forgotten the left-hand side. You are saying that the left-hand side is 0 because you acknowledge that the initial velocities were 0. And then we are saying that right is positive. So if we are saying that right is positive, we can sub in that the 3.2 is moving at negative 0,4 because this is left. So it must be negative. And we get that the 2.6 is moving at 0,49. I don't know how much you like momentum, but this makes sense because this is a bigger mass, so it has a smaller v than this one, which has a smaller mass and a slightly bigger v. It's not really an easy factor, but the difference between 3.2 and 2.6 is 0.6. So the ratios, if you can also do it with ratios. I wouldn't suggest it, but just the bigger block mass trolley doodad will move slower than the smaller one. So I got 0.49, and I'm happy with it being 0.49 because at least that makes sense. And then I take that 0.49 and I just simply sub it into a distance, speed, time calculation. So this, you could have done this instead. Speed equals distance over time. The speed is 0.49. It's the answer from there. And the time is 1.3 seconds. And so you get 0.64 meters. So they're calling this an equation of motion, but basically it's just the speed, distance, time calculation. And you get 5 marks for that. I think we can all get at least 3 for that, because we can put the formula, then we can put the substitution. We know that it's 0 and we know those numbers. That would already be 3, but we could actually even do this one as long as we get an answer here. So whatever answer you get here, if you put it into some sort of speed, distance, time calculation, you'll get that mark as well. So we could actually get 4 marks here maybe. We could definitely get 3 for getting it wrong. So 60% for getting it wrong is pretty nice, actually. Then, that's finished now. Oops, sorry. So now I must call up this one. So 4.3, they tell you that, so now they give you another number, and they tell you that the average force while it was in contact was, with the spring, was 4.2. We are now going to use the FAT formula. F net delta T is equal to delta P. And they say calculate the time it took for the spring to extend to its natural length. So we are definitely going to use the FAT formula now. And how you're going to get this one wrong is you're going to use the wrong units maybe. Oh, no, actually it doesn't matter for this one. If you're using the FAT formula, your unit needs to be Newton seconds. Because the unit for impulse, which is F net delta T, the fat part, this part here, this is called impulse. And the unit for that should be Newton seconds. But if we just write this off the formula sheet and we sub in 4.2, you will get a mark. So that's all you need to do. It's 3 marks. You will get a mark for simply doing F net delta T, and then see here, this mark. You can get this mark for just subbing in the 4.2. Why is the 4.2 negative in this case? Why is the 4.2 positive in this case? So if we continue with the fact that the right is positive. If we continue with right being positive. So again, I did tell you the momentum questions, the direction is incredibly important. The numbers that we are using here. The numbers that we are using here are all for trolley 1 or trolley A. These numbers are for trolley A, and trolley A is moving to the left. Trolley A moves to the left. So the force acts to the left, and the velocity of trolley A goes to the left. Trolley A was moving at 0 meters per second in the beginning and 0.4 to the left afterwards. If you decided in the beginning to make right positive, please maintain that throughout the question. And so for this little calculation here, you're going to get 3 marks. So you can get 3 marks for that. You're just solving for delta T. And you can get 2 by just writing the formula from the formula sheet, this one over here, writing this formula from the formula sheet, and just subbing in the force. It would be better if you could sub it in as negative if you are making right positive, and maybe just say this. Directions are very important in Newton's vertical projectile motion and momentum. Please practice with your directions. Please make sure you kind of at least a little bit know what's going on. But also equally, if you don't know what's going on, always just write a formula from the formula sheet and put any sort of number from the question into the formula. You will get at least 1 mark for doing that. This last little question is an explain question, which is maybe a bit bad, for 3 marks. So let's just read through it quickly, or let me read through it. Trolley B is now replaced by trolley C. So this guy over here is replaced with trolley C, which has a larger mass. And the trolleys are released, and you get the same force as for 4.3. How will the magnitude of the velocity of trolley C compare to the velocity of trolley B? It will be smaller than. Remember, I did tell you this just earlier. It will be smaller than, because the bigger the mass, the smaller the velocity. So how we argue physics things always is we need to use a formula. So the formula would be the fat formula. So the formula would be the fat formula. So we can use this one. And this one, the F net is exactly the same. It's 4.2 still. The time, they said it's for the same period of time. So so all of this stuff is exactly the same. All of that stuff is the same. And this part here will be VF minus VI. All of these numbers are the same. Everything on the left-hand side is the same. The mass has gotten bigger. So the V part must get smaller. They are on the same side of the equal sign, so they are inversely proportional. And so if the mass got bigger, the velocity must get smaller. The initial velocity is still 0, so that doesn't make a difference. So this little story here, that's what they're saying. And you can do it with the formula. See here, they gave the formula, and they say F net is constant, M increases, so delta V decreases. So what I've said with symbols, they are saying with words. And you can at least maybe guess the less than. The heavier you are, the slower you move, typically, in physics.